Hello, everyone, and welcome to today's SANS webcast, YARA, Effectively Using and Generating Rules. My name is Carol Ott of the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are Erik Van Buggenhout, SANS Certified Instructor, and Didier Stevens, Internet Storm Center Handler. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Erik.
Thank you, Carol, and thanks everyone for joining us. So let's, before we get started, a short introduction on what we will be trying to achieve in this specific webcast. So as you may see in the slide where we've also got Steve Sims here listed as a host. Unfortunately, he won't be here today because, well, we've got you covered with myself and Didier. One of the main things that we're going to focus on is indeed YARA, its different use cases, the way it can be used, but more specifically, how we can actually develop or write or effectively write YARA rules. So who are we? Short introduction on that is me, myself. I've been involved in quite a few webcasts since I started working on SEC 599, which is one of the courses that SANS is heavily pushing with regards to how to implement effective controls to prevent adversaries from getting into the network. Usually Steve does this kind of an intro, so mine might be a bit rusty, but here we go. The whole idea of that course is looking at how can we, next to explaining how offensive techniques work, what can we do to actually improve our defenses and the way that we respond to typical incidents, issues, adversaries in our networks. One of the main topics that we discuss is, according to a kill chain structure, we walk through different parts, different activities, or different actions that an adversary can take in our networks. One of the main tools that we use as part of well, our detection and response capabilities is YARA rules. YARA rules have been around for quite a while. They're pretty new when we look at the overall age of this industry. We move very fast, but more and more we see this being used by different vendors, by different tools, and there's quite some different ways on how they can be used effectively in the environment. That's what we want to focus on today. So my name again is Erik. I'm based in Brussels, and I mainly look after 599. With me here today, I have Didier Stevens, who's also based in Brussels. He's an analyst together with me actually at Enviso, but he's also an Internet Storm Center handler for the SANS Institute. So he's got quite some experience on malware detection, incident response, digital forensics. That's really his piece of pie, I'll put it that way. So what we'll be looking at today is first looking overall at what YARA is and how it can be used. And then we're going to be looking into a demonstration, and we're actually going to work on a couple of developments. We're going to look at a specific sample, and we're going to see how we can effectively write a good YARA rule for that. So let's get started. So what is the agenda? What is YARA? What are some of the different YARA use cases? How it can be used? How it, well, cannot be used, or what is not a use case for YARA? After which we go into YARA rule writing. As always, as Carol already mentioned, if you have any questions for us, please don't hesitate to let us know. We'd be happy to respond to any specific questions you may have, any specific insights or remarks. We're always happy to get your feedback on those. So first of all, what is YARA and how it can be used? Now, YARA is a free open source tool developed by Victor Alvarez of Aristotle. There's a bit of a myth on what it stands for. Could be yet another regex analyzer. That's the one that can be used. Or the acronym could also stand for yet another ridiculous acronym. There's a few of these floating around. Lovingly, however, it's nicknamed as a pattern matching Swiss Army knife for malware researchers. So its aim is to effectively match patterns. So analysts, researchers, and incident responders in general can define patterns that can classify or categorize different case samples of malware according to their potential origins, their uses. It's looking for similarities between different samples, looking for similarities between different files, so we can actually categorize and classify malware samples en masse, so in large volumes. It's important to note that YARA is very much more of a static analysis tool as opposed to dynamic analysis, where you have your typical sandboxing that takes place. That being said, there are a variety of modules that add on top of YARA additional capabilities, which we'll also discuss. It's available as a standalone tool for Windows, Linux, Mac OS X, but it has been integrated into many other tools. So a lot of different tools they use, and they rely on the YARA engine to do detection. So we're going to look at how to obtain, develop, and use YARA rules in our environment. So VirusTotal is one of the main, well, the big ones, or one of the big boys who uses YARA rules very effectively. They also offer different services that rely on YARA rules. One of them, which we'll discuss a bit later, is, for example, the retro hunting, which allows malware researchers and security analysts to define YARA rules, which will then hit on different VirusTotal uploads, which is, of course, a private commercial feature of VirusTotal, but it allows malware researchers to identify similar files once they have developed the YARA rule for a specific malware sample, which provides additional insights, of course, and, of course, opens up possibilities to analyze more samples. So why YARA, or why was YARA developed? Up until it was there, it was hard for independent malware analysts to, well, have a publicly available tool to easily detect and classify large volumes of malware samples. Of course, we can match and classify them based on a hash, like a message ID, an MD5 or a SHA-1, if you will. But that's, of course, very specific, because that means that you just look at one specific file. It's one specific one. And if there's a slight difference in the file, of course, the hash is completely different. YARA allows us to use an engine that can be used to recognize different patterns, so we can potentially find maybe, let's say, a link or relationship between two samples. That could be that they include many similar keywords, which might indicate that they have a very similar purpose or use case. Might be, for example, that we identify debugging paths which are still left over in the executables. That could reveal that we are looking at the same kind of developer, so it's the same person who wrote these executables, and so on. So the idea is to allow us to detect samples, malware that's potentially related, and develop rules on that, or rules for that can be shared publicly. As we will see, YARA rules are pure text, so they're not a binary or a compiled version, it's a pure text. So they're pretty easy to understand, especially when we have some experience with reverse engineering, although it's not required to understand what the YARA rule is looking for and how it's been developed. That being said, developing YARA rules, as you will see, is an acquired skill. There is quite some experience and expertise required to write effective YARA rules. But the rules themselves, when they are developed, they are usually quite understandable and they do make a lot of sense. To prove that point, here's a very simple YARA rule. It's a bit too simple, but it's a an easy example to understand what the YARA rule looks like. Here we can see a rule which is called or named wcry_mutex. The whole principle of this rule is looking for the mutex used by the WannaCry malware, which was, well, probably not unknown to you. And we know that mutex that was used was the MS WinZones cache counter mutex A. That very specific string, however, was present in many of the different WannaCry samples or executables, which means that we can look for that string to find potentially linked WannaCry samples, or potential WannaCry samples that we do not yet know. We can very easily create a condition on that and say, okay, we want to hit on $mutex. Do note that the YARA rule is a Boolean condition. It's yes or no. So it provides a hit, yes, or it provides no hit, no. There's no reporting. There's no, a malware sample does not get classified, for example, on a scoring of 0 to 10. It's a Boolean condition, yes or no. Now, as you can imagine, this specific rule is quite vulnerable to potential false positives, things that could go wrong, maybe even, well, false negatives, things that we miss, because this is a bit too simple, right? If we optimize this very slightly, you'll see that we start adapting it a little bit. Here we can see a new version of this same YARA rule, and we're looking for wcry_mutex, so same YARA rule again. But now we have two strings. We have $mz equals mz, and $mutex, the same one, MS WinZones cache counter mutex A, but we've added a few keywords here. We've added ASCII, white, and no case. Now, allow me to explain. The $mz is, of course, the second string that we're looking for. In the condition, you will notice that we are looking for $mz at 0. The whole principle here and the whole idea is to look for the string mz at the start of the file. So we're looking at Windows executables. That's what we're trying to do. So we want to avoid, for example, let's imagine that there's a document and maybe even a small node file which has that mutex in there. We want to avoid that one. As long as the file does not start with an mz header, or if it's an executable, then we know, okay, we don't want to look at it. On the $mutex, the additional keywords that we have, ASCII, wide, and no case. Here we've optimized the way that we match the strings. We're looking for both ASCII strings, hence the ASCII keyword, wide for Unicode strings, and finally no case to make it case insensitive. So those are small additions that we add on top of the YARA rule to make them work better. This is of course not yet a perfect rule, it's even far from that, but it gives you an idea on how you can further optimize. We already notice here now as well that we have a condition which is twofold, so we need the file to start at to start with an MZ, and it needs to include of course the mutex that we already did. Now this is an example of a real YARA rule. We've taken the liberty here to take a YARA rule of probably one of the most active YARA rule developers out there. His name is Florian Rott. We'll discuss him a bit more in just a second, but here we can see a developed YARA rule, which is available. It's freely available online, publicly available. You can see some meta information, which is usually context about the YARA rule. How was it developed? Who's the author? Here we can also see 3 different hashes. Most likely those are references to the files that were used to develop the YARA rules. So you've got 3 hashes there, 3 specific files that were used to create this YARA rule. We can also see the campaign that this was linked to. So we're looking at the backdoor here that was linked to the Greenbug incident. You can see here a bunch of strings, which have a bit of an, how would I say, a more anonymized name, $x1, $x2, $x3, and then we have a bunch of S's as well. We'll see in the condition in just a second why these have a different first letter, but you can see here the same thing. We see the ASCII and wide coming back. The full word actually means that these strings will only hit if they are delimited by non-alphanumeric characters. Meaning, for example, if you're looking for, let's say, the full word domain, if you find a string which is my domain, that wouldn't hit, because my, of course, is then linked to domain. So domain is not ended or started with non-numerical characters. That's the principle. So you're looking for an exact match, if you will. If we look at the conditions here, we see a small variation on our trick where we used MZ to identify executable files. So the uint16 hit there, which we'll focus on that one in just a second. It's something that Didier will explain once we start looking into performance tuning. So this is very much more of a performance addition or a performance fine tuning that we're doing instead of matching on the specific MZ string. We'll also see that here we are using a certain file size. So we've added smaller than 1000 kilobytes. And you can see that we are using a variety of different conditions there, where we're using both the X strings and of course the S ones as well. So there's a variation there. You can also notice that we are using 3 of them. So it's a very almost linguistic language, if you will. So 3 of them means, of course, that we're looking at 3 of these conditions. So that allows us to be quite flexible in how we want to adapt. You can also imagine that we can then start whitelisting certain false positives once we see that our rules are not generating the right or the expected hits. We can start adapting them further. So up until these were all very much basic YARA rules focused exclusively on pattern matching. So those patterns could typically be text, or they could also be binary patterns. But YARA has additional modules and capabilities which can be added to the platform, which are typically hosted or included in modules. Some of the most used modules and some of the most well-known ones include PE and ELF, obviously for executable files for both Windows and Linux environments. So what we can do there, we can actually use, for example, PE header fields in our YARA rule once we import the PE module. So this, of course, allows greater flexibility, and it allows us to be a lot more specific in how we develop our rules. So we don't just have to be, how would I say, dumb in our pattern matching, but we can actually focus on very specifically that part of the PE header needs to match this specific string, which is, of course, gives us a lot more flexibility and allows us to create more fine-tuned YARA rules. An interesting one is the Cuckoo module. Now, this actually works in both directions. So Cuckoo has a plugin where it can scan a file that you submit to the Cuckoo sandbox with YARA rules. On the other hand, you can actually also create an integration where YARA can submit the files or the samples into Cuckoo, and you can write a YARA rule which includes, for example, I want to know if the file, for example, sets up network connectivity with a certain host, and then I can add a string that matches that host. So I can add Cuckoo results in my YARA rules. So it's twofold, which is interesting. It works in 2 directions. There's some others which make a bit more sense or which are easier to understand, like the magic to use file magic to understand, okay, but what's this specific file doing? There's hash, allows creation and magic of hashes based on parts of a file, and so on. Important to note that these are all well documented. You can find a lot more information about them on the YARA website. Well, these are rather straightforward. Important to note, though, is that depending on the type of YARA scanner that you're using or the type of YARA tool, you have to make sure, though, that the modules used in your YARA rule set are also present or supported by the scanner. Otherwise, you will get rule errors, syntax errors, and they, of course, wouldn't work, and you won't be able to leverage them. This is an example of, for example, an example, for example. This is my Belgian English. Here's an example of YARA rules with modules. This is a pretty basic one, but you can see here this is a rule created by Dragos, which is obviously a firm focused on ICS security. And we can see here that this is looking for certain crash override related malware samples. This one is very specifically focused on hashes, and we can see a reference towards a certain PDF. Now here we've just written one YARA rule, which is looking for well, no strings, but it's purely looking at the very specific hashes of known malicious files. So you can see that this is a rather straightforward rule. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9 different files which are linked to that specific campaign. And so we're just looking at the SHA-1 hash. You can see that you can actually generate a SHA-1 hash on either the entire file, as we are doing here, because we are creating a SHA-1 hash from 0 up until the maximum file size, so the entire file, or we can create it of a smaller portion of the file as well. So we can be quite peculiar in how we want to use that. That's just one example where we are using, in this case, the hash module part of YARA. So how do you get YARA rules? First of all, public APT campaign reports, investigations. The majority of large vendors typically provide YARA rules as part of their IOC sets. So this is really one of the de facto standards, YARA rules. More and more you will see that those are part of the standard IOC lists next to IP addresses, domain names, and so on. There are a whole bunch of free public YARA rule sets out there. Florian Rotz hosts his own signature base, so the YARA rule base that he uses for a lot of his tools online on GitHub. There's the YARA rules projects as well, and there's probably a lot of them that I'm missing, but there's a whole bunch of these out there. Of course, public and private intelligence feeds, once you're subscribed to a commercial one, you will get these. If you look at MISP, for example, the malware information sharing platform also has support for YARA rules. So based upon the sharing settings that you configure there and the type of information that you're sharing, you will also be able to of course, get YARA rules from such a system as well. And you can develop your own YARA rules, which we will discuss in just a second. So what tools support YARA integration? Well, obviously the official YARA binaries, which are released by VirusTotal, which are indeed YARA scanners that you can use. There's Cuckoo Sandbox. So the sandbox we already mentioned has built-in YARA support. There's VirusTotal as one of the, well, as the inventor, if you will, of YARA. They, of course, have a lot of YARA support available. This goes from you doing retro hunting, where you can define YARA rules that can search into their previous uploads to see if they have any hits, to defining a YARA rule that runs on every single sample that gets uploaded, so you can know of new samples which might be related to one that you already know. There's Volatility, which is a memory forensics framework that you're probably not unfamiliar with. It also has support for YARA rules. There's the majority of EDR tools, several AV vendors as well, starting more and more to support these YARA rules. And of course, there's Florian Rotz toolkit, which includes Loki, Tor, Spark, which are IOC scanners, which have a very big focus and well, they very bigly support YARA because it's one of their main signature categories. There's an interesting page, which is on GitHub, which is an awesome YARA list, which provides an overall overview of different YARA-related projects as well. It's inspired by the awesome PHP and the awesome, what is it? I think there's another one of those, but there's quite a few of these, very much focused on finding or listing good resources, community-driven resources that can be used that support YARA. I'm just going to switch very quickly here to my browser for a second. So this is, for example, the signature base by Florian Rotz. I know I'm moving quite quickly, but this is very easy to find. You will see that all of these YARA rules, they're typically classified or categorized per APT groups or related campaign names. So you'll see here quite a few well-known ones, APT 28, 29, 30. But next to that, you'll also see, if we go down here a bit, there's items like, if I get there, so these are all cybercrime related. The gen ones are typically focused on specific, on tools. For example, Kerber roasting, Kirby Mimikatz. There is, for example, here, generic anomalies, generic cryptors. Once you get into generic, you'll see that there's a whole bunch of them which are focused on just identify potentially suspicious items that could be suspicious but are not confirmed to be malicious. These include, for example, YARA rules just to detect Office macros. That's quite simple and quite straightforward, but it also shows you the power of YARA. It's not only about very specific pattern matching for very specific campaigns or known strings, but you can also search for things that you wouldn't expect inside a certain file. This is the YARArules.com project, very typical as well, a very big repository, also on GitHub. So all of that is, of course, free. If we then look into some scanners, this is Loki, made available by Florian Roth. So that's their free toolkit. They also have a commercial scanner, but this one has built-in support for YARA rules, pulls in the signature based by Florian Roth automatically, and well, quite effective in what it does. One last one I wanted to mention is OS Query, which is more and more being used as a tool to automatically collect information about your endpoints, typically Windows, Mac OS, or Linux systems. They have a built-in table for YARA matching as well. So you can actually use YARA rules to then start looking at your endpoints to detect, for example, hits on your YARA rules. Also quite effective and pretty impressive to see that work. So how to use YARA rules? Well, we mentioned that already. Mainly useful to scan files or memory to detect hits. A couple of example use cases. I'm sure you can think of more, but it's of course to sweep your environment for YARA rules and YARA hits. Using YARA rules in a prevention mode. Just as an example, Clem AV, which is an AV vendor, they're a free AV product. They support the YARA rules as well. So you can actually add YARA rules to the antivirus or the signature database of their AV product. Which is more and more being done and supported. You see that those YARA rules are coming a bit out of the dark and more into the spotlight. So they're more and more being used by, for example, the EDR tools, the AV vendors. So more and more we see that kind of support appearing. We can use, as a malware researcher, YARA rules to classify or categorize malware samples. We can do hunting and matching using, for example, VirusTotal. Forensics and investigations, for example, using volatility. So there's different forensics toolkits as well that have built-in support for YARA. So you can use your own imagination. It's only limited by that because it's a pattern matching mechanism. So it can be very flexible in how it can be used. Now, we want to have a look at some YARA rule writing because that's some of the more interesting work. We're going to look at two different ways, which is generating YARA rules, and there are tools for that. For example, YARGen, and writing your own YARA rules. So I will hand over the word now to my dearest colleague Didier, who's going to show a short demo on how to effectively write these rules and how to generate them in the right way.
Okay, thank you, Erik. So I'm Didier, and here in this demo, we are, sorry, so you can see my screen now, I hope. So here in this demo, we are going to show how you can take an existing malware sample and analyze it to create effective YARA rules. So the sample that I'm going to use is something we have analyzed before. You can find more information on our blog. This malware, this Windows malware, does a privilege escalation. And it was found about half a year ago on VirusTotal. Maybe you remember there was quite a buzz about a zero-day PDF that was found on VirusTotal with an Adobe Reader 0-day and a Windows 0-day. So here we are going to analyze that executable, that malicious executable, and see how we can write malware samples. Here at the end, you have the analysis, but let's switch here to the command line. So I have my sample here in the malware folder. And okay, assume that you have found this malware sample in your environment on one machine and that your antivirus had not yet detected it. You realize that it is a 0-day, and so you want to scan all your environment for this malware. You could use a hash, calculate the hash of this sample, and then look on machines for the hashes, but then you might miss other samples that are similar but don't have exactly the same hash. So that's a problem that you can solve with YARA, and I'm going to show you how you can do this. Now this executable, I have it open here also in my binary editor. So, and a Windows executable starts with MZ, and it's actually a PE file. So you have the MZ header, and then here you can see PE. So that's the start of the PE header. And then of course, a lot of binary data, which is the code, and sometimes you will find strings. So, and that is what we are going to do here. We are going to use some of the strings that you find in this executable to build YARA rules. So for that, I'm going to use the strings command. And so I'm on Windows here, so I'm using the sysinternals string command that you can find here on the Microsoft website for sysinternals. But of course, if you use a Mac or a Linux machine, you already have the string command. So I run the strings command on my sample, and let me pipe this through more. And what this will do, this tool, is find all the strings in the executable and list them to me. Now you see here a lot of meaningless strings that's in behind, that is actually code, so we are going to skip over them until we find something that is more readable. Okay, so here you see kind of error messages. And let's continue. Kernel32.dll, you will find that in a lot of Windows executables. Those are API files, API commands. So that's also classic to find that in a Windows executable. So let's continue to find something more specific, something that can help us identify this sample. Also months and dates, yeah, that's classic. Okay. So, and here we found something that is interesting, like here set post create object, and here an HTTP, and all other strings like here a file name. So those strings are good IOCs to try to identify this malware. And here is even a better one, this one here. Remark that it ends with PDB. So this is actually a path, a complete path to the program database. This is something that is present in executables, Windows executables, when they are compiled with Microsoft compilers. By default, Microsoft will include strings like that, path like that. And what this actually is a peek. This gives us a look into the machine of the developer of this malware, because this tells us the complete folder structure that he has on his machine, where his malware that he's programming and that he's developing is located. So this malware is called set IME info proof of concept. That's actually the vulnerability that is exploited. And in the release folder, that's where the malware is generated. And that is information that you can find here just as a string in this executable. So that is a very, very good IOC that is very reliable to identify all malware and different versions and compiles that were generated on that machine. So we are going to use that. Let me scroll through the end. Okay, so we are going to use that in our YARA rule. Now, one thing also that you need to know is the strings that we found. Is that an ASCII string or is that a Unicode string? And I'm going to do a grep for that string, find string, like this. So for PDB, and here I have the string. Now there is an option in strings -A, and then I'm only looking for ASCII strings, like this, okay? And I get the string, so I know that this is an ASCII string. So now I can use this in my YARA rule. So I'm going to copy this to the clipboard with the clip tool. And now I head over to my editor, where I create a new file. And here I'm going to create my YARA rule. So rule, and let's call this demo PDB. And then here, brackets. Now, when you write YARA rules, one of the interesting things to add is metadata. Now, that's not mandatory. You can add your own metadata, like, for example, Didier Stevens at Enviso. And the interesting thing here is also that you explain why you are doing this. For example, look for PDB of malware sample. And then if you base your rule on an existing sample, it's always interesting to include the hash. These are all string definitions here, and you can write anything that you want as long as it is a valid string definition. So that's a metadata. And now we are going to look for strings. And the string that we are going looking for, let me call it A. That is here our complete path to the PDB, like this. And then I just have to add a condition and say that the condition, we just want to find that string. And then I can save this. Like this. Demo PDB with extension YARA. I have the habit of using extension YARA. Sorry, Florian Roth often uses JAR, the three-letter one. Now I'm going to demo this, but this will actually not work properly, and I will explain that immediately. So let me save this. And now here I can invoke YARA. And on Windows, I can invoke 32-bit YARA and 64-bit YARA. If you have a choice, always use the 64-bit version, because that version can read more files into memory, and so you're less prone to have a memory error. Then I provide the name of my YARA rule, and now here in this example, I'm just going to give the file like this. Okay. And now here, like I told you, we get an error. And that allows me to show you how you can interpret errors. So in this file here, demo PDB, YARA, line 7, there are several illegal escape sequences. And what is actually happening is the following here. All those backslashes, they actually have to be escaped, because a backslash in a string, like in many programming languages, like in C, has a special meaning. And if you want to have a real backslash and not something like a \n, which means a new line, then you have to actually use 2 backslash characters. So let me do a search and replace. I replace a single backslash by 2 backslashes, like this. And I do this for the complete string. I can save this like this. And now let's run this again. Like this, and then you get a detection. So that is a typical detection for YARA. It will give you the rule and then the file where it was detected. An interesting option here when you use this, when you are developing your rule, is the S option, because that will show you all the strings that were found. String A here was found, and where is what was found. Okay. Now, of course, when you want to use this to search on a machine, you're not going to do this for a single file. You want to scan the complete disk, and that's what I'm going to do here, my complete folder. So with option R, I'm going to do a recursive search. So I search here in the complete folder. And you can see actually that now I have 2 hits. I have my malware sample, but also nodes.txt. And nodes.txt, those are actually my nodes where I also have that IOC, that string. And that is why it is triggering. So that's something we probably don't want. So what I'm going to do is adapt my YARA rule so that it will only take into account Windows executables. And I'm going to do it as follows. So I define another string, mz, like this. And I want that mz string also to be found at position 0. And then also string A, like this. Because remember, in the PE file, mz here is at the beginning of the file, so that's a quick trick to recognize Windows executables. So let's run this again. I probably did not save. like this. Okay, and now you see it's only the executable that is detected and not the nodes. So that is important, that you know what you are looking for and that you tailor your rule accordingly. Now, if you are going to scan a lot of machines, let's say, for example, all the machines in your environment, then remember that what is actually going to take most of the time is reading all the files on the machines to be scanned. So it's interesting to have several rules. So what I would do here in this case is actually have two rules, because you can have more than one rule. You just have to make sure that they have a different name. So I'm going to use rule MZ. And then here, I'm going to use my simple rule with just A. This one I know will generate several false positives, but it's something that I can discard just based on the name. But I'm doing this because it has no performance impact actually on doing one rule or two rules. What takes most of the time is reading the files and looking for the strings. So if I run this, like this, here you can see PDB detects the two files and PDB MZ only one executable. Now, when it comes to optimization, to make your rules a bit more performant, you can actually do the following, and you have to know a bit how YARA works, the YARA engine. Every string that is defined here will be searched for by the YARA engine before it executes this condition. So first it will look for strings and then do the condition. And looking for small strings like that will yield quite some false positives. And because those are just 2 bytes, it's likely that you find them at different positions in executable files, not only at the beginning, but just as it happens on other locations inside that file. So what you can do to avoid this is actually not look for that string. So we remove that string. But we are going to do a test. We are going to read the 2 bytes at the beginning of the file and check if it corresponds with MZ. And that can be done with a function that is defined in YARA, and that is called uint16. And that stands for unsigned integer 16 bits, or 2 bytes. And we're going to read this at position 0. And what we want to find there is MZ. So in hexadecimal, that is 4D5A. Now, what you also have to know about YARA is that functions like this, uint16, and you also have uint32 and uint8, for example, all those functions, they are little endian. So that means that they interpret the bytes that they read in a sequence from right to left, that the least significant bit is here and the most significant byte is here. So we actually should have to write 5A 4D. But there is a variant of that function, and that is the big endian function. So if you type BE at the end, you have the big endian function, and then you can just type X4A 5D like this. Let me save this. Let me also remove this rule so that it doesn't trigger. And let's search in malware. And I have a syntax error. That's a demo effect, of course. 9. No, sorry, that has to be equal. It's not at, it has to be equal. So equal is 2 equal characters. Okay. For the 5A, and it is not detecting it. Sorry, I made a typo for the 5A. You see that I'm doing this live. Okay, and here we have our detection. So that is one of the tricks where you can improve the performance of your YARA rules. That is by changing the detections here, not working with short strings, but here actually reading data out of the file. Also, this here the AND operator is just lazy evaluation. So if this would be 0, then it would not evaluate A, because if this is 0, since this is an AND operator, it will always be 0 and false. Now, when we talk about YARA rules here with strings, so the important thing is to understand what strings that you need to select. And that can of course be a problem if you're not very familiar with that. Like here, browsing through all those strings and knowing which strings are important. But there is a quite easy solution for that, and that is YARGEN. So the tool that Erik spoke about, written by Florian Roth, it's a Python tool that allows you to automatically generate YARA rules for samples that you provide to it. And that's what I'm going to do now. So first of all, this YARGEN tool also uses a lot of strings in a database that it has. So when you use it for the first time, you have to do an update of that database, and that will download all those files. It's about 1 GB, so it takes quite some time. I'm not going to do that here because I already did it. And secondly, because it takes a lot of memory, you have to actually use the 64-bit version of Python. So that's what I'm doing here, like this. Then I can specify YARGEN in YARGEN master, like this. And I will tell it to look into the malware folder to generate rules for me. So I'm starting this, and that will take some time, a minute, I think. But like all those famous television chefs, I already ran it, and I take it out of the oven here, and this is the rule that was generated by YARGEN for that sample. And the interesting thing about, it looks more complex, but if you take a look, you have here metadata, strings, and condition. So it's quite similar to what we have seen, and also a module here, import PE. And here, if you take a closer look, you can see our PDB file. So YARGEN has realized that that PDB part is very important, and so it has included as a string with an I score. All the strings here that start with an X, those are important strings, strings with an I score, and the one with an S, have a lower score. And that is why in the rules, for example, that the condition is we want at least one high scoring string or 4 strings in total, because YARGEN realized that those strings are quite specific, while those are less specific. And the way that YARGEN is able to do that is because of all the databases that it has about all the files that contain strings, like API functions that I showed you. YARGEN knows that those strings are common in executables, so it will not use them, or at least use them with a low score. So YARGEN here has finished. You see that it analyzed, extracted, and also nodes. But okay, we don't want an YARA rule for that. And so let me open that generated file here. So the rule set import PE file. This one is for my nodes, but I actually don't want one, so I can just delete that one. and this one here is for the executable. And then also here at the bottom you have super rules. Now super rules are the following. YARA can work with global rules, rules that are used by other rules. And if you have many samples, then it can be that YARA will generate some of those super rules, but that's not the case here. Now, the interesting part here, when YARA has generated this for you, you can actually also start to modify it. You can just remove some of the strings if you don't think that they are that important. You can just start to delete them. And then also, of course, you have to adapt the condition here. Another thing that YARA does, it does the test for the MZ, like I explained. Another thing that it also does is the file size. It will check for files here being smaller than 200 kilobytes to limit the files that it has to scan. Also, it uses the imp hash module. So it compares this with the hash because it has realized that that imp hash for this sample is quite specific. It also has a list of known good imp hashes, and this one is not in there. So it generated one with imp hash. And an imp hash is an import hash. So Windows executable will import DLLs. And the imp hash is an import hash, and it will contain, it's a hash of the names of all the DLLs that it imports. So that was the rule generated by YARA. Now, if we go back to strings, then I can show you something more. We're almost there. Okay. So these are the strings. This is actually a VBS script that is written to disk to be executed and do the privilege escalation. Okay. Here you see the path where it is written to disk, so that would also make for a very good IOC. And then you see this here, warning, it is over, right before the PDB. That is also a very interesting string if you understand what it is about. And it's something that YARA has not identified, but let me explain. If you do a bit of reverse engineering, or if you actually execute that sample in a sandbox, you will see that it displays a message box. And that message box has title warning and then text it is over. So warning is actually warning, but it's a typo. The malware router made a typo, it didn't type warning, but warning. And the thing is that warning is quite specific. If I do a Google search for warning, I have about 1,500 hits. And so that's not much for Google. So warning would actually also make a good IOC to use in a rule. So this is something that, of course, YARA cannot know. It doesn't know the actual meaning of those strings, but it is something that you can learn with experience, that typos can be a good IOCs. And of course, the rule here, then if we make that rule, would just be a rule warning, sorry, I made myself a typo, where you say strings warning like this, and then condition .a as $A. Of course, if you want MZ files, then again you also have to do that uint 16 0, and let me do the big endian of 4A5D like this, and okay, So, and then save that rule and testing. So that is something that a generator will not be able to do for you. Specific things like typos. Typos can be good IOCs, and that of course is something that the generator doesn't know about. But it's something that you can add. You can take a rule generated by the generator, modify it, and then add something like that to have a more specific detection. Now, and to conclude, I just want to show one more thing, and it's the following. So what I'm looking here with YARA, when I'm searching, is the executable itself. And here in my directory, I have another example of that sample, and that is the one that is one that I packed with UPX. So UPX is a packer for Windows executables, and with that you can make smaller Windows executables, but most importantly also is that the content will be compressed, so you will not be able to find the strings in there. If I do strings on this malware here and go quickly through it, okay, let me go back. Here you can see a couple of strings, part of strings that we saw before. That's the effect of the compression, like here, box user. Okay, and here also part of the manifest. So it doesn't actually contain strings that we can use. But there is a solution to this, and that is actually the antivirus, the open source antivirus that ClamAV, that Erik already mentioned, because ClamAV also support YARA rules. And I have a version here of ClamAV in my folder. Let me just quickly show you. So I have my demo rule, and I will copy this into the database of ClamAV. That's the only thing that you need to do with your YARA rules. If you want to use your YARA rules into ClamAV, you just need to copy it to the database folder. And then let me put the malware sample here into the malware folder, so the UPX and the executable and the nodes. Now, let me go back to my rule. Okay, yeah, my rule is still okay. And now I'm going to use ClamAV. So that's Clam scan that I need. And I will scan the malware folder, and I think I need to do option R. Maybe those metadata rules are a problem. Like this. Let's try this again. Okay, so actually this version does not understand UN16 BE. So that is the thing with YARA on ClamAV. It's not the newest version. So let me make a quick modification. Let me just remove this and do just the test for A, like this. And run this again. Okay, and now you see that it found the string in the malware sample, but also in the UPX sample. And that is the advantage of using ClamScan or another tool to run your YARA rules. That is because an antivirus program like ClamScan is aware about much of the packing and compression that is used to obfuscate malware. And it knows, for example, about UPX. So what ClamScan will do is it will scan the UPX file as it is, but then also it will realize that it is UPX, so it will unpack it in memory and then again scan it with the YARA rule, and then it will be detected. Okay. So that was my part of the demo. I hope you found this interesting, and I think now it's back to Carol.
All right, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question is, does Mandiant Redline support YARA, or is there some way to convert YARA to Open IOC?
So I'll take this one. That's actually a very good question because I don't use Redline that often. Although YARA rules, well, they're quite expandable and can be adapted. I would imagine there should be some support for it, but I haven't looked. I can double check, but it should be easy to find online. I'm not sure, Didier, if you have any experience with using Redline, using YARA rules.
No, I have not, but I've used other tools, of course ClamAV, but for example, I know also CrowdStrike supports YARA rules, so there are several tools that you can use.
All right, thank you. If an AV vendor has their own signature for virus, why use YARA rules to extend that? Does it add value?
So I'll create a first response maybe. The one thing is, if an AV vendor already has a signature, then indeed there is less use to generate your own YARA rule. That being said, the one downside we always have with an AV signature is, of course, that they have it's proprietary. It's usually their own. They've developed it themselves, and it's much less open. So you can only use it in their specific AV vendor engine. So the usability of that signature is a lot less. That being said, YARA rules are, of course, most effective when there's not yet a rule that can actually detect them. But the principle of the YARA rules is that they are, of course, interchangeable. So you can share them with, for example, Intel partners, and you can, of course, use them in many different tools. So I think that would still be a very valid reason to, even if there is a signature available, to still write a YARA rule as well.
Yeah, and also the thing about the YARA rules is that you can make them much more generic than an antivirus vendor will, because you have to realize an antivirus product, when it has a false positive, it will also delete the file or quarantine the file. And so that's a problem for an antivirus vendor. So an antivirus vendor tries to avoid false positives as much as possible. While if you're in a hunting mode, you're less concerned about false positives. Of course, if you get dozens of them, but I mean, YARA or your other scanners, they will actually not delete the files. Like I showed you here with ClamAV, when I give no special options, it will not delete the file. So that means that you can make your YARA rule less specific, and of course open then to more false positives, but since no deletion, no problem. But then if I illustrate that with the PDB part, if you remember, it starts with /code and then a date. I could just use that string and then a wildcard and then say it has to end with PDB. And with that, I will identify all other programs that have been compiled on that same machine, whatever it be. If it is stored in that folder and compiled in that folder, with that rule, you will detect it. So that's a very generic rule that you can use for hunting, but of course, that's not suitable for an antivirus.
Thank you. Will the malware sample be made available anywhere? I'd like to practice.
The sample can be found on VirusTotal, and I think also that it's on more of the virus sharing websites like Joe Sandbox, if I'm not mistaken. But I write that down, and I will communicate that information later so that you can download it. We will not provide it, the sample itself, but we can point you to a place where you can download it.
All right, thank you. How do you scale this up to an enterprise network?
So that's maybe a good question. So scaling it, I think there's a couple of potential use cases for that. So what Didier focused on was writing the actual YARA rules, which is always going to be a bit of an intensive process because, of course, there's YARGen, but if you want to manually, of course, adapt them and make them good, then you need security researchers, malware analysts who can do it. That being said, to use YARA rules effectively in enterprise environment, you typically want a tool that can easily sweep your endpoints, and quite often you'll be looking in the direction of potentially an EDR-like tool if you have any available. Then you think of the typical suspects there, like a Carbon Black, CrowdStrike. I'm not. We of course remain very neutral on vendors, but a lot of those tools, the EDR tools, they will typically support it. Otherwise, there are some tools who can sweep your environment for YARA rules as well. If you check out the awesome YARA repository, I think I mentioned it's in the slide, and you can also Google for it. It has a ton of projects which typically include endpoint tools that you can use to sweep the environment. But I think usually what you want to avoid is installing one specific endpoint agent or a tool on every endpoint just for the purpose of YARA scanning, because that's going to become heavy. And typically we only want to have so many or a limited amount of agents on the endpoints. So that's where you hope, and you typically leverage your either AV, next-gen AV, or your EDR tool to be able to do the scanning. And that's what you see, that most of those vendors, they are moving in the direction of building in YARA support for this specific reason. So I hope that was an answer.
All right, thanks. Once you have a solid YARA file, what's the easiest way to push it out of your endpoints? Or is AV the easiest way?
I think this one is probably very much linked to what I just talked about. It's a very similar question. So that's one of the easier ways of doing it like this. If you have a tool available like that, an EDR tool or an AV engine that has support. Otherwise, there's a couple of open source projects which aim to fulfill this. And again, that's where the awesome YARA rules project is. The GitHub file. It's a pretty extensive list of ways of doing that.
Yeah,
right.
I would like to add that most AV products don't support YARA rules. It's only a couple of them, like Clam AV, but most of them will not support it, so you cannot use your AV product most of the time.
All right, thanks. Is there any course from SANS where they teach how to create YARA rules, or something that expands upon what has been covered in this webinar?
At the moment, we don't have any dedicated courses available that focus on YARA rule development, at least to my knowledge. It's being covered in quite a few of the courses, though, like 599, like some of the forensics courses. There's a couple of shorter trainings available, I know, out there, which cover YARA rules in depth. So I do think that what I can do is I'll have a look and see what's available, what's out there, because I think there's even some open source material or some free stuff as well that's available out there. Though the material on actual YARA development is pretty limited still, or the training available for that. You'll typically look at having the reverse engineering skill set first, and that's where a typical 610, the forensics class from SANS, comes into play, and then using that, of course, effectively to write your own YARA rules. But if you want to learn how to write the YARA rules yourself, you're going to have to start typically with the reversing, understanding how malware works, and focusing on that first.
Yeah, but what I want to add is, if you can already understand pretty well what the strings mean in an executable, if you can get pretty familiar with analysis, just doing string analysis, and a lot of analysts just do that string analysis, then you can already go a long way if your malware sample is not obfuscated or packed. Then Florian Roth has also a couple of resources on how to write effective YARA rules. But I must say that there is quite some focus on performance tuning of your rules. So, for example, if you can avoid regular expressions but use wildcards or jumps instead, that will improve the performance. So there is quite some focus on that. But I want to say that first, you need to focus on getting your rule to work with whatever you're familiar with. If it is strings or regular expressions or just bytes with wildcards, just do whatever you're most familiar with to get your rule to work. And only when it is working to your satisfaction, then I would say that you would start to look into performance tuning. If you need that, if you plan, for example, to scan a whole set of machines, then yeah, performance tuning can be important. But that's, for me, is typically the second step.
All right, well, we're out of time, unfortunately. Thank you so much, Erik and Didier, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.